Hello, my name is Kent Lavorne, General Manager of VMek Sorting Technology. VMek is a company focused on building high tech machine vision based solutions for the agricultural market. We'd like to take an opportunity to introduce you to our technology, to the machines that we've built, the applications that we've solved, and a little bit about our vision for the future. For us at VMek, everything starts with our base technology, which this kind of involves high speed image acquisition, proprietary lighting, which allows us to reduce shadows and illuminate defects, as well as our high-speed image processing and our high-speed reaction, which gives us the ability to divert a seed, for example, and eject it. The application that the Metrics Analytic Color Sorter is for color sorting. This was the first machine that we went to market with back in 2014. What makes this product unique on the market is, in addition to getting the physical separation, kicking out the bad, we get the data on each individual part. And how we do that is, as the seed falls, I isolate each part. Here, there's a captured a front image and a rear image in this scenario, and we're able to get almost a 360-degree view of a seed. From there, we do some high-speed analysis and outputting length, width, area, color distribution, some other shape information that's available in real time that you can output for each individual seed. So applications that we've solved with this machine are like refuge and bag separation, damage and disease, quality analysis, those kind of things. So one of the other machines that we've built with this base technology is our Abacus high-speed counter. So it still has the same concepts where we're using high-speed imaging, lighting, high-speed image processing, but in this case, everything's kind of been simplified. We're only using a background light just to get a silhouette of the individual part falling, but we still are able to isolate that, make sure that we've separated and created a unique part, and then we count it. That's the most important part of this. It does output data, some length and width and area and such, but mainly the goal of the Abacus is to do high-speed counting. Another application that can be accomplished with the Abacus high-speed counter is if you integrate a hopper scale and put it in line, you can weigh the product, count it, and then output a count per pound. For example, as the seed is packaged by weight but sold by count. So here, this gives you an inline real time. You can cycle it every couple of minutes if you want, count per pound, or 1,000 seed weight if that's the way you do it. It does both. So like all of our technology, it integrates into a PLC using discrete I/O. Or for a more sophisticated integration, you can use OPC to change recipes, set outputs, and view status and such. As we've installed many machines in the marketplace, we've learned about various options or different applications that the customer needed, and we were more than willing to accommodate. Could be something as simple as integrating a barcode scanner so that you can track the lot coming in and the lot exiting the machine. As well as, like the Abacus, we can integrate into the metrics also a count per pound or a hopper scale. It can give you the count per pound or total kernel weight. This is often used in line, for example, in an automatic production line to get the count, to sort some of the big stuff and the small stuff, as well as sorting out the diseased material. So often when this is installed in a automatic production line, we could remove three pieces of equipment, a simple sizer, a counter, as well as a color sorter. So it's kind of a 3-in-1 for an automatic production line. And as our applications come in, we just adjust to what the needs are. This is one configuration. We have a configuration where we have a scale for the accept, a scale for the eject, which allows you to count how many accepted, count how many ejected you have, as well as get the weights on both of those. Another little bit more sophisticated application that we've tackled is by putting gating below the accept, which allows us to divert seeds. So we could run to, let's say you want 1,000 seeds to go to position A. So we run 1,000. We're rejecting all the while, but then letting 1,000 seeds to go to position A. Then we put an output to switch a gate, which will now divert and do another count to position B, another count to position C, and so forth. So that's the metrics has the ability to do what we call target counting, counting to a number, either stopping or switching on the fly with this gating we just talked about. The Abacus also has the target counting abilities. Talking a little bit about the next steps for the metrics, we're in the process of transitioning the metrics uh, from a software standpoint from a metrics analytic color sorter to a metric seed classifier. And how that's different is very simple but very powerful. So the current form, the metrics analytic color sorter, outputs data on each individual part, you know, linked with color distribution and so on. The seed classifier will be crop specific, for example, soybeans or corn, but will not just give you just lines of data about the individual part, but it'll tell you exactly what the part is. Is it a split? Is it a purple stain? Is it a bleeding hilum? Or whatever that may be on the defect side. And also, we're working towards classifying the hilum color, the seed coat color, and giving each individual part a classification. This will allow you to really grade the quality of the product that's the incoming material. And we'll talk about how that applies to the overall system and kind of our vision for the future a little bit later in the video. Another solution that we provided the industry is the Profile 3D Seed Sizer. This machine uses complex lasers and cameras to generate a three-dimensional point cloud of each individual part in real time as it's falling. The goal of this machine is to replace your traditional shakeout where you're doing your size predictions. It'll output the percentage of medium rounds, medium flats, large rounds, large flats, etc. So as you can imagine, most of the machines that we've described at this point, the metrics, the abacus, the profile, these are all built for either the lab environment or for a small batch production, for example. It could be small continuous production. But here we've also now evolved or implement our technology for a full production product. This is our element production color sorter. Although it's not much bigger than our metrics, the capacity is much greater, 10 times greater. So this machine you're looking at here as a single module can run 100, 120, 25 bushels an hour of corn or soybeans. The data, we don't get the data on each individual part, but we are tracking the data on the defects. So kind of using that same classification concept we talked about previously with the metric C classifier, we're able to classify each defect so that way in real time you know what percent odd rounds or splits or purple stains or whatever may be coming through the machine at any given moment. Of course, this is a modular production color sorter. And, as you can imagine, 100 bushels an hour is not going to be good enough for production. So we have this base frame concept, which is the first in the industry for color sorting to offer a modular assembly technique. So here you can install the base frame one time, the utilities, dust collection, product coming, product going away. And then, if you're a small company, you can buy a large base frame in only one unit and then expand as your production grows. Or if you're a big company, you can just populate, 8 of these in a row. And then as the technology changes or as your needs change, we can quickly slide out the module, push in some new technology to upgrade the whole system at a much lower cost than you would if you had to replace the whole system. To this point, we've told you about our individual products and the applications that they've solved. But for us, we have a bigger vision for the future to help run seed production plants more efficiently with more knowledge of what you're doing. For example, we're working currently actively on a soybean project where we can sample the bins that are in the field so you know what you have in inventory. Or using a seed classifier to analyze the incoming material at the plant. Then that data can be analyzed and sent the data over to your color production sorters for their initial recipe. And as they're running, you kind of see what defects you're seeing, and they can auto adjust. And of course, back in the tower, just before bagging, you can have another seed classifier count per pound, which will give you the count per pound prior to packaging, and your final analysis, your final quality analysis, which that can be used for your automated quality reporting or feedback to your color sorters. So we'd love to talk to you more about all of these in more detail. So reach out to us and let's have a face-to-face. Thanks for your attention. Appreciate it.